businesses, and daily lives, we often treat them as the source of truth, like they know everything. But today we are going to take a step back and see how these incredibly accurate systems sometimes confidently lead us to digital illusion, and more importantly, how we can mitigate these to keep our AI grounded in reality. So let's get started with today's topic, and that is AI hallucinations, fact versus fiction. How we can navigate the myriad of generative intelligence. So let me first define what hallucinations are. So basically, this is a four-part journey. So how we can start by defining what hallucination actually is. So for the professionals in the room, we can dive into technical why, the probability traps and database biases, and we can also look at high-stakes consequences in the real world finally, and we can discuss how what strategies we can use to mitigate them, like retrieval augmented generation, reinforcement learning with human feedback, which can be helpful to manage these. Now, let's start with the section one, how we can define the illusion. So before we can fix a problem, we have to understand the fundamental nature why this problem is coming. Why is the system capable of passing the bar exam also capable of insisting that 1 plus 1 is equal to 3? So this is what illusion is. So the, for those who are new to AI, the term hallucination can be misleading. So in humans, it is a sensory error, but in AI, it is a confident falsehood. So it is very important to understand that an AI does not know anything in the way you or I do. It is a prediction engine. It works on probabilistic terms. So when it hallucinates, it is not essentially lying because lying requires intent. So instead, it is simply producing a response which is grammatically perfect and highly plausible, but factually very ungrounded. So it prioritizes being helpful and fluent over being silent when it does not have the answer. So what are the primary causes of it? Basically, why all of this happens. So you can think of these as stochastic parrots. They repeat the patterns they have seen in trillions of pages of text. So first, they are probability engines. They do not consult any database of truth or something like that. And secondly, when they encounter sparse data means topics that are not very well covered in their training. They don't stop. They try to fill in the gaps using the most likely words from unrelated context. So finally, training bias, which means if the internet was wrong or contradictory, the AI will also be wrong. So now let us look at a bit of math here. The formula which you can see on the screen here represents autoregressive logic, which means the model essentially calculates the probability of the token t given all the previous tokens. But here is the catch. The model uses its own previous outputs to predict the next word. If it makes any tiny error at the start of the sentence, that error becomes the source of truth for the rest of the sentence because the mathematically it follows a path of high probability. Even if that path leads off to a falsehood, it will propagate forward because it is essentially optimizing for syntax and not semantics. We also have to talk about source divergence. If your training data is a mess, your output will also be a mess. By 2025, we have seen that nearly 28% of training data for large language models contain conflicting facts. When the foundations are corrupted, the model has to choose which truth to follow, often leading to a hallucinated blend of two different facts. Now let us look at the anatomy of errors, like how basically these errors are classified. So not all hallucinations are same. and understanding the type of error helps us choose the right tool to fix it. So basically, there are two broad types of errors. The first one is intrinsic errors. The first one is intrinsic errors, where the output contradicts the model's own provided source or previous sentence. These are self-contradictions. For example, if it states that a person died in 1980, and then it tells that their wedding happened in 1990. So we generally split errors into these buckets. So intrinsic errors, another example can be the AI tells you that a person was born in 1990 and then says that they graduated college in 1995. Basically, within 5 years, they completed all of it, schooling also, graduation also. It's logically inconsistent with its own response. Another type of error is extrinsic error, which are more dangerous. The response is perfectly logical and self-consistent, but it is just wrong in the real world. It names a fake CEO or cites a law that does not even exist. So these are harder to catch without external verification or human in the loop validation. Now, what are the different modes of fabrication? So there are three main ways these errors manifest in the real scenario. The first one is fact creation, which is simply making up history. So essentially, the model tries to invent non-existent events or deaths or discoveries which are fictional in nature. It does not have any reality. So fact creation is simply making up history. Another is reference creation. It is perhaps the most frustrating for researchers. The AI will give you a real looking URL or a legal citation that leads to a 404 page not found. And the third one is reasoning gaps, which means correct facts are used to reach a logical conclusion. So these occur when the facts are right, but the AI hallucinates the logic which is connecting them. Now let us talk about the real world impact of these AI hallucinations. So this is not just a technical curiosity, it has a massive dollar sign attached to it. Let us look at the impact. So the cost of overconfidence. We all remember the Google Bard demo, right? And that a single hallucination about the James Webb Space Telescope led to a $100 billion drop in the market cap in the 24 hours. So this basically highlights the reputational risk in businesses. If your customer facing AI is hallucinating, you are not just losing a customer, you lose the trust of the entire market. And for businesses, this unfaithful nature of AI is the single biggest barrier to full scale adoption. Now, let us talk about the notable failure cases. So, as you can see here, in the legal world, Mata versus Evianca, this became a landmark for what not to do in the legal world. Lawyers were sanctioned by the court for citing six fake cases in which they admitted that they generated using ChatGPT, which is another large language model. It hallucinated and it generated fabricated cases, and because of which lawyers were sanctioned by the court. In the world of aviation, also, as you can see, Air Canada's chatbot hallucinated a discount policy, and the court said that the airline was liable for what the bot said. Like, it cannot say that AI said it and we did not as a part of its defense. So it had to implement the discount policy it laid out. So here we can see hallucination rate by different tasks. As you can see from this data, the more complex the task, the higher the risk is. Translation is relatively safe at 8%, but when you get into legal citations, the rate jumps to 27%. So if you are using AI for high complexity factual work, you are effectively playing Russian roulette with one or two chambers loaded, basically. So increasing complexity correlates directly with the higher fabrication rate. Now you can see here. uh, the user perception gap. The real danger here is 55% of users still behave 55% of users still believe that AI is a search engine that will always provide factual information. This trust gap is where businesses fail, and we have to train our users to understand that AI is a creative engine first and a factual engine second. Now let us move on to section 4 and discuss about the strategies how we can mitigate the risk of AI systems. AI hallucination. How do we fix that? Is we have four main tools. RAG is our strongest tool. We will talk about that in a moment. Uh, Bear with me for that. RLHF is how we fine tune the model to admit when it is unsure. RLHF stands for reinforcement learning with human feedback. Prompt engineering is the simplest. It tells that it is like telling the AI, do not guess when you don't know the answer. You tell me that I don't know. So this can itself reduce the errors by half. And the last one is consensus checking. It involves asking three different models the same question and flagging discrepancies. Like you ask three different models the same question, and it is very rarely possible that all of them hallucinate at the same time. You may take a moment to read this. The most dangerous AI is not the one that is wrong. It is the one that is wrong but sounds absolutely certain. This is the psychological trap. Research has shown that hallucinating models actually use more confident language than accurate ones. And we have to learn to be more skeptical when the AI sounds more confident. Now let us look at grounding with retrieval augmented generation. So instead of letting the model guess from its memory, we force it to search a verified database of the company's document. It then summarizes that specific data. This will reduce the error by over 70% and provide an audit trail with citation. Now, now what is the path ahead? Like we are now moving towards safety layers, which means that using one AI to polish another, we use observability tools to monitor output, cross validation to check fact between models, and we always keep a human in the loop for high stakes decisions. So let's see how we can do that. In 2022, we had stochastic parrots, but by 2025, we have moved to reasoning models like OpenAI's O series, which can think and verify their internal logic before they ever show you a word. This future is towards the systems that are mathematically verifiable. So basically, what we saw is AI is a probability engine and not a database. Fluency does not equate to accuracy. Fluency is not the same as accuracy. Retrieval augmented generation is your best friend for business. And finally, never automate a critical decision without a human sanity check. Now, the goal of this generation of technology is not just to make AI that can talk, it is to make AI that can be trusted. We are moving from a digital illusion to a reliable reasoning partner. So, before we conclude the session today, I want you to look at this checklist. Like if you are deploying your AI, are you auditing your prompt? Have you grounded your data? Are your users aware of the risks involved? You can use this as your roadmap for a safe AI deployment. Like you should always be auditing your sensitive prompt. You can implement measures like grounding using retrieval augmented generation. You can train your users to give effective prompts to AI and how you can monitor the hallucination rate that your AI model is giving you. And last but not the least, involve a human check at the last. Because if there is any hallucination produced by the AI model, it will always be validated by a human. Best validation is done by a human only, because AI models today may not be always accurate since they work on probabilistic engines. So this is it for today. Thank you for your attention.